Hi, Praveen. We are live now. Feel free to start when we are ready.
Okay, yeah, sure. So hi everyone. Today I would like to discuss about accounts and transaction types in Klaytn. So first of all, I'm Praveen. So I've been part of the Klaytn ecosystem development, and today we'll go through what is account types and what are the transaction types and how it benefits Klaytn and what kind of features we get out of it, and we'll also see the demo at the end. So for those who are new for Klaytn, Klaytn is a layer 1 blockchain, and it's launched in 2019 and it's backed by Kakao. And then now Klaytn Foundation is a non-profitable organization. And then we are using a Istanbul Byzantine fault tolerance consensus mechanism, and all the nodes are run by validators, one of the top companies. So currently we have 27 as of now, 27 global companies who run the validators for us. And then we have a service-centric hybrid blockchain architecture, which means apart from having a mainnet, the Klaytn layer 1, we also support layer 2 solutions. So for companies who wants to have even better performance, like for some gaming companies who needs even better performance regarding the speeds and all, we are also supporting layer 2 solutions for them. And one of the unique features of Klaytn is the account and transaction models. So like it supports, because of this account and transaction models, we'll be able to give features like fee delegation and also assigning different roles and also multi-signature kind of features. And then as part of the recent Klaytn initiatives, like we've been focusing mostly on the RWA, Metaverse, and the gaming side. So this is about the Klaytn. So now regarding our topic, so first of all, so the problem we have a problem of what if the private key is exposed. So generally, if a private key is exposed, we either have to create a new key, new private key pair, and then we might have to migrate all the funds to the new private key. And even like if we share the, I mean, if we share the private key pair, like if we share the public key with our friends, and or maybe if that public key is used in different platforms, maybe we might have to update in all of those platforms. So I think this is one of the major problem. So the best solution would be, what if like we can change the private key? So based on this idea, so like Klaytn have come up with how about decoupling the private key pairs from the address. So address is the generally the address. Generally, whenever we create an account, we have a key pair, which means we have a private key and a public key. And the address is generally derived from the public key. So this is a normal Ethereum way. And we use most of the EVM chains, we have these kind of structure where the account is derived from the public key. So, so because of this, will not be able, we will not be able to update a private key, or if we lose the private key, so then we'll have these kind of problems over here. Now, what if like we decouple the key pairs with the address? So it will solve many problems. Like whenever we decouple it, we can even update the key pairs, and we'll also be able to get more features related to this. So something like, for example, if we were able to decouple the private keys, so we can also have multiple key pairs for that address. So by having multiple addresses, we can provide features like multi-signatures and also role-based features for each and every key pair that we hold, which are tied to that address. So this gives a lot of security and also a lot of usability for the user. And then if we consider the transaction types, so generally a transaction has a same kind of structure for any transaction that we make. So in Klaytn, so because of this, we will face some problems like latency and also like unnecessary memory of for each and every. So having a same structure for all of these types, we might have to, even though the variables or these things are not used we might have to put that one in the state so that, it's unnecessary memory for the blockchain. So the idea is to split each and every transaction and have a different type of transaction. So in Klaytn, we have a different transaction for each and every type of transactions that we make. So because of this, the memory is saved and also the performance of it improves a lot. So we have made some changes related to this as well. And then, so once we make, so because of the transaction model that we have done, so we were able to solve this problem where what if you're a company and then maybe you wanted to onboard lots of users, and then each and every user, whenever he wants to interact while onboarding, generally he might have to pay the fee. So instead of him paying the fee, what if the company can pay for onboarding the user? So this problem, this is a very common problem in lots of onboarding use cases, and maybe so these kind of gas fee delegation. So we have introduced a new feature called gas fee delegation. So with the help of this feature, we'll be able to avoid these kind of things. So this will help the user adoption more. 1 second. Yeah, this will help more user engagement and adoption. So we were able to achieve this fee delegation by using a fee delegation transaction type, and also by a role called fee delegator role. So generally in this use case, if you see, so a user will have a role called signing role, and the service provider can act like a fee delegator for him. So whenever a user performs a transaction, a service provider can pay the fee for the transaction that user initiates, and then we can make a transaction onto the blockchain. So here, even though the sender doesn't have any claim, he doesn't, or we will not charge anything for the sender, and the fee payer would be the service provider. So in this way, because of the transaction types that we have, we were able to achieve a fee delegation mechanism. So to summarize, we have in the account models, with the help of account models, we were able to change the private keys, because we decouple the private key pairs, the key pairs with the address. And we were also able to have multiple key pairs for a particular address, which means we also can give a feature of multi-signatures. And we were also able to give a role-based keys. As part of transaction models, with the help of transaction types that we have created, we were also able to achieve a fee delegation mechanism. So this is how we were able to achieve this this features. So for account model, so generally we have account types of, generally we have a contract and EOA accounts. So we have introduced a new field called key. So generally this key, we have these types, majorly a legacy key, which is similar to any other EVM, a single key value pair, where the address is derived from the public key. And then we have a public key account type, which means we have decoupled the address to the key pair, which means we will be able to update the key pair. And then we have multiple public keys, with which we can also give a multi-signature type of mechanism. And we have a role-based keys. So role-based keys, in the sense, majorly we are providing three roles, which means one role can have a transaction role, which means that the role which the key pair holds can only make a transaction. So, and then another role can have an account update, which means it can make only the updates of an account. So it'll be helpful for updating other people's private keys, all the key pairs. And then we have another role called fee payer, where this particular key pair attached to the fee payer can play the role of the fee mechanism. So in each and every role, we can have multiple keys also. And in the transaction, we have various transaction types like value transfer, which is like generally when you wanted to transfer some clay or something, like we can make use of a value transfer. And we have a value transfer memo if you want to attach an extra memo. And we have a smart contract deploy type, a smart contract execution, and also an account update type. So along with this, we also have a fee delegation mechanism for all of this transaction types. So the transaction types also have a fee delegation type. So these are different types for the fee delegation. So if we consider the structure of a value transfer, so generally, in a typical Ethereum, we give these the this fields as an input, but in Klaytn, because of introducing the decoupling of the key pairs, we might also have to send the extra details like sender address and also the sender signatures. Just because as we have decoupled the address with the key pair, we might also have to send the because the public key is because the address is not derived from the key pair, so we might also have to introduce a new sender address as part of each and every transaction that we do. So as part of fee delegation value transfer, so apart from sender's details, we also have to give a fee payer related details. So Klaytn is basically EVM, like Ethereum fork, and so obviously most of the tools of Ethereum should work for Klaytn, and we are also supporting all of the, along with our own features, we are also supporting the Ethereum features as well. So you can use most of the same tools whichever we are using in Ethereum, like MetaMask, Truffle, all this all these tools. And we have Klaytn Scope and Klaytn Finder, which are explorers. So along with so generally in Ethereum, we have the JSON RPC ETH underscore. So we are supporting the Ethereum equivalent parts. Along with that, we have also added a Klaytn related namespace, which will provide Klaytn specific features. So if you have to if you have to make use of Klaytn related features, then you might have to use some of the Klaytn tools. And we also, so as part of this Clay namespaces, we also have like governance related contracts. If you have to communicate with voting and these kind of things, then you might have to make use of Klaytn related namespaces. So I think, yeah, we'll deep dive into the demo now. So first, so this is Klaytn Online Toolkit, where we have various functions of where we have defined all the account types. We can make some transactions over here, and we have various tools over here. So here first, I would like to show. So in accounts, we understood that we have different types of accounts, like basic account. Basic account is similar to any other account where it has a tight coupling of key pair and the address. So the address is derived from the key pair's public key. So basic account can be created shown over here. So you can see the code over here. So with the help of this code, you'll be able to generate a key pair. And then this is the address derived from it. So let's add some balance to it. Yeah. So once the key pair, so along with creation of account key types, we'll also do a value transfers from each and every type of an account that we create. So let's copy this, and maybe we can also let's try to send a transaction with the help of this key pair. So I would like to introduce you to another link that we have. So we have a dApp kit where we added some snippets for it. So you can just grab those snippets into your local. So this is the structure of the dApp kit, and I've added some snippets over here. So first we will see how to make a value transfer, like sending a clay from a legacy key. So now we have created a legacy key over here, and then you can just copy the key ring which is created over here, which contains the public key and the private key information. You can just replace over here. So basically what it does is, so we are using a library called Kver.js, which is equivalent to a Web3 JS. So actually we make use of this one to communicate with the blockchain, with the Klaytn blockchain, to have unique features of Klaytn. So here, as you see, we are making use of a transaction called value transfer, and then we'll be able to get a hash of it. So now I have replaced that account key of legacy, and then now we'll be able to make a transaction. So now we have done the transaction. You can see the details of this transaction by going through Klaytn Score, which is an explorer. So this is the address that we have created. So this one, as you see here, the account key is account key legacy type, and then we have made a transaction right now. Similarly, we can try other accounts also, where something like account key public, and then we'll also try other things and also see how to send the transactions from each and everything. So to go with a account key public, first of all, we need to create a basic account, and then we might have to upgrade to a account key public. So now we already have account key legacy, and then let's try to upgrade that one to account key public. So in account key public, we are decoupling the key pair with the public key, with the address that is exposed. So here you can just copy paste the private key that we have created as part of a previous step. And then you can generate a new private key over here. So now what we are doing is we are trying to upgrade the legacy account to the public key, which means here we are updating a private key also. So as you can see here, we are updating the private key of the previous one, but the address will remain same. I think once we upgrade this one, we'll try to make a transaction and see whether we were able to see the same transaction in the previous account into this. So because we are upgrading the private key over here, so I think let me copy this private key and just put it over here. So this is the previous private key, and this one we are trying to upgrade over here. So now we have done an update on this particular account. Now let's try to copy that and make a transaction. So I've created a function called value transfer account key public. So where, as you see here, the address remains same, but the private key got updated. So now let's make a transaction and see how it's showing in the Explorer. As you can see, with the new private key that we have created, and also the account key got updated over here, it shows public instead of legacy. So we have updated a private key and we have initiated a value transfer. So now, being the address remains same, but the key pair is updated over here. So this is the advantage of having an account key public. Now let's explore even other account types, which is account key multisig. So for that also generally we need a basic account. So let me create a basic account and then convert that into a multisig. So multisig account where we have multiple key pairs and they act like a multisig functionality. All these features are part of a Klaytn, are present in the Klaytn core protocol itself, and we don't have to do anything else. So now let's try to add some fun to this. Now we can just copy this key pair and then maybe I'll just put it here. Now we can navigate to the multi-sig account key. We can paste the private key over here. So now we are trying to update the legacy account to a multi-sig account. So where we will have multiple key pairs which are tied to a same address. So after giving this, so generally as you see here, so we can give we can do a multi-signature thing over here. So where we'll give a threshold, and then we can also provide all the private keys over here. So for now, I'm just generating from the auto-generating from this tool. So here I'm giving two private address, two key pairs, and the threshold is 2. So which means all the keys over here has to sign. So now I'm trying to update the key from account legacy to account multi-signature key. So now the address remains same, but we have attached multiple private key pairs, and then we'll be able to achieve a multi-signature feature over here. So now let's try to make a transaction from this. So I'll just copy this output that we got after making a update. And then we have a value transfer functionality over here. So we have value transfer multisig over here. You can just replace the input from this. And then here what I'm doing is, so once I have this one, so first I'm making a transaction. First I'm creating a signature. And then I'm creating a signature from the first account, which is from the first private key. And once I get a result, I'm getting a signature from the second account. And once both are signed, I'm making a final transaction. So this is the multi-signature feature that we could achieve with this type of account. So now let's perform the transaction. Yeah. So basically, this is the transaction that we have done. So this is the basic value transfer. So now the account type has become an account key multi-sig, and we can also add weights for each and every multi-signatures that each and every multi-signatures that we give over here. And now let's try the other account type of account, the new account type, which is the role based. So generally multi-signature, like everyone has similar kind of role, and they're just based on the threshold that we give, the people have to sign for that particular transaction. So, but in the role, we have generally three types of roles. One is a transaction role, where that role, the set of people comes under that role can be able to do only transactions. And we have a role for fee payer, they can pay the fee. And we have a role called account update, so where they can update the account. So these are the three roles that we have. So now let's try to create a legacy account initially and then try to make a role-based account. So we can just create a legacy account, get some fun to it. And then you can navigate to the key role-based account, and we can provide the private key of the legacy account. So now we are converting a legacy account into a role-based account. So here, as I mentioned before, we have three types of roles. So we can give any number of private keys for this particular role. So it need not to be one. And we can give any number of roles, and we can give multiple private keys for these particular roles also. So, but for now, as part of this demo, let's try with one role for each, one key pair for each and every role. So I'll auto generate the keys over here, and then finally perform the update transaction. So now this update makes a blockchain call, and then it will update the account type to a role-based account. And then I've created a function called value transfer role-based, which will help us to perform the role-based transaction. We can just replace the data from here. So here we are making a transaction so that so here we are making a transaction called, we are making a value transfer transaction. So we just need a private key of the value transfer, the transaction role. So, but we don't need this particular roles private key. So as part of this example, if you see, I'm making the signature only with the transaction role. So which is the first one. So I'm making the first records, I'm making use of the first records private key, and then I'm initiating a value transfer transaction. And then we'll be able to see that the Clay is transferred to the other account. So address will remain same for legacy and this one. So you can just copy the public address that we gave. And then yeah, we were able to transfer the fund with the help of the transaction key itself. So similarly, if you have a fee delegation role, you'll be able, I mean, fee payer role, you'll be able to make only the fee payment. And if you have an account update, only you'll be able to make an account update, and you'll not be able to make a transaction. So this roles plays a major role, major things. You can find different types of use cases for these types of things. And we also have, so whenever we perform this value transfers or maybe like smart contract deployments, So while we do this, we can also do some fee delegation on it. So let me also show this part. So we can copy the same key that we generated before, the role-based key details, and we can put it here. And then, so in this transaction, if you see, we can either give a fee payer public key, a different key pair, and then we can also generate the account over here, which means that it need not to be, everything need not to be at the same place. So these three key pairs can be, and individual accounts which is present with individual members, and they can interact with each other to make a final transaction. So here, I think I'll just make use of the existing role that we already have, which is this current fee payer itself. And later on, I'll show you a use case where, where we'll have a different fee payer with a different sender transaction, with a different transaction role. So and then we'll also see that kind of use cases more. So for now, we'll try to make this transaction. So here, if you see in this method, I'm making a transaction with transaction role. And after that, I'm making a fee payer signatures. And finally, I'm initiating the transaction. So here, the transaction sender will not need not to pay any fee. And then the fee payer will only pay the fee for the transaction that you have made. So these kind of use cases, mostly we can see for free pricing or for free trial kind of use cases, or maybe like giving a discount to users for certain time. There are lots of use cases around this. So let's try to execute this part. So this is a transaction which we have done. So here, as I mentioned, we are using the same fee pair, which is derived from that online toolkit, but we can also replace the fee pair with another key pair. So it need not to be generated from the same place, or all the things need not to be together. So they can also be separated, and each one can interact with good UI UX. Okay, so I think we have covered the account legacy, the account key public, multi-sig and role-based, and we have tried different types of transactions with these type of keys. And now we'll see few other use cases and few other applications. So first, I would like to show the fee payer flow. What are the use cases for fee payer? So if you open the Klaytn DAppKit, so we have added a fee delegation application over here, which is an end-to-end application which has a front end and back end. And we have few other use cases also, but let's see the fee delegation part. So in this particular application, what we were doing is a sender from the front end will sign the transaction and then send the transaction details to a backend. So the backend can have a different fee payer address, different fee payer the private keys, and finally the backend will be able to make a transaction and then send to the blockchain. So here we can clearly see the difference of the private keys which are holded by the sender and the fee payer. I think let's try this example. So you can just like pull the repository of this particular thing, and then we'll try to run locally. So here I have a fee delegation. First, I would like to show you how this application is. So in the backend, we have, so in the backend, we are using a private key. So that can be configured in the .env file. You can give a private key and the public key of that particular fee pair. So which I'm using on the backend. So I gave a sample details over here. And then the front end interacts with the a Chrome extension wallet called Klaymakers, and then front end will be able to make a sign signature, and then that particular transaction is sent to the backend. Now backend will actually pay the fee for that particular signature. I think this flow we can see it with this example. So you can just log in, enter into fee delegation, and run the application. So here, like I mentioned, first we'll connect with a wallet, and so in this example, we are trying to deploy a smart contract. So we have a dummy storage contract over here, and we gave some values called key value pairs. We gave these values. And then currently I have connected with my Klaymakers wallet. So this is my address, which is shown over here, and my balance is here. So I'm making a transaction from here. So in this use case, I need not to have any kind of Clay for making these type of transaction where a backend system or some other person will pay the fee for me. So, but here as part of this front end, we'll make a signature for the transaction, which need not to have any kind of Clay. And then once we get that signature, we'll send that to backend. So for having a signature, as you see here, we are not transferring any amount or the fee for this particular transaction. Once this is done, this particular signature we are transferring to the backend, so that backend will be able to pay the fee. Now, as you see, the contract is deployed, and then you can see the details of this particular contract. So this is a contract, and then when you go through the transaction details, now we can see that the from address is the account which I've used from the Klaymakers, and the backend is the fee pair 0xe1, which I've configured in the .env for the backend, which is over here. 0xe1 is the public key. So here, as you see, we have segregated uh, the guy who is making a send transaction and the fee pair with the help of the transaction types that we have. So this is example of fee delegation, and I would like to also show another example. So let's say we have a use case where a company provides the keys to the user so that a user will be able to make use of that key. And at some point, let's say if he lost the private key and if he wants to update the private key with the help of a company, so a company then will be able to recover that private key for him. So in this particular scenario, we can make use of a role-based account types where the initial account is created by the company and a role of signing or the transaction role is given to the user. So, and then we'll also provide a private key for that particular user having a transaction type, transaction role. And then in the backend or as a service provider, they will maintain the fee pay. They'll be playing a role of fee payer and also an account update role. So these two roles a service provider will play in this role-based accounts. And then whenever a user requests for updating the private key of a user, with the help of the account update role that a service provider is having, he'll update the private key and then he can forward the private key to the user. So this type of use case, let's see with an example. So we have a project in this particular repository called role-based account update. So you can just enter into that. So here Backend will contain the fee payer and also the account update related key pairs. So for this in the .env file, you might have to mention the fee payer public key and private key, and also the account update public key and private key. So this can be a legacy, a normal account type keys. So you can just create a simple keys of pub, and then you can just give those details over here. So this two things goes into the backend. And then a front end, as part of a front end will just request the key and to the backend, and then backend, it will generate the key even for the user, along with the keys that we already have. Will make use of a fee payer and account update, and will dynamically generate a private key for the user. So these logics you can find in the backend router over here. So mainly we have two methods called register, two routes called register and update private key. So in the register, if you see, I'm making use of a fee payer and the account update, which I've configured. And dynamically, I'm creating a transaction role for the user. And then I'm actually creating a new account, new role-based account. And then I'm forwarding that details to the user. So this way, a backend or the organization who is hosting this, they'll be able to maintain the account update key and also fee payer key. And then they'll be able to give the transaction key to the user. And then whenever a user requests for update private key, as the company is already holding, or as the backend is already holding a fee payer private key and account update private key, if a user loses the key also, if the user loses the transaction key also, whenever he requests any request for the company, they'll be able to dynamically generate a new key again for the user, and then they'll be able to update that as part of a role-based account. So this is how the backend works, and let's see this application once. So let's say this is kind of a semi-custodial wallet, where even though you have a private key, a company will be able to help you with updating a private key if you lose. So let's say we are creating an account with a company like this. So let's say once we create an account, a company is actually, or the backend is actually giving you the transaction related key. And then a backend will already have a fee payer account and also the account update related roles key. So, and then they'll be only giving the transaction key to you. So once they give the transaction role for you with the private key, you'll be able to make a transaction. So this is the private key that we got from the backend. And then now you will be able to make any type of value transfers. So I'm just sending to the same address with some amount. One second. Yeah, we are getting insufficient balance. So as a user, so whenever user initiates a transaction, so as this user itself is holding a transaction role, so this person needs to have a balance. So let's have some balance for this user. And once you have balance, you will be able to initiate a transaction. So you were able to make a value transfer from this particular user. So this is the first private key. Let's say we lost this private key. Let's say we lost this one, and after that, now we don't have any private key, and then we'll be able to request a private key to the to the backend or to the organization, so that you get a new private key. So this is our old private key, and this is a new private key. So with the new private key that has updated, so now you'll be able to make the same transaction again, and the wallet address would remain same over here. So you can see these details in Klaytn scope. So now we have made an update over here. So this is an update, and now we can make a transaction again, like a value transfer again, with the new private key that we have. So we were able to make a transaction, and then the details are tied to the same address itself, because we just updated the transaction role with the help of a backend. So you can see the same details again here. Yeah. So we were able to make a transaction after getting a new transaction key role with a new private key. So with the help of this role-based account, we can have these type of use cases which are helpful for in these scenarios where user doesn't have to bother about losing a private key. So, and then apart from this, I would like to just go through all the other things that we have. So you can find all the details of accounts and transactions from these links. And we also have a Web3 Klaytn, which contains an extension of Klaytn, extension of ethers, and it also contains a Python libraries. And also maybe you can also explore this one, which will also give a deep insights related to the transaction types and account types. And I've already shown the Klaytn Toolkit, which contains various functions, various features. You can also have lots of examples for how to interact with Klaymakers. And we have a Klaytn DApp kit, which contains the basic use cases. And we have this website where you can find all the functions, all the types of transactions over here, which is related to Klaymakers. So you can try it out all these transactions, how for interacting with Klaymakers. So if you are developing some dApp, I think this must be handy. And then we have few articles, to read about the multi-sig role-based Web3, and we have a Metaverse knowledge kit which covers related to even contracts, oracles, bridges. Now, if you are interested to explore more, you can also have a look at this. And we have already seen the explorers over here, faucets, and we have a Klaytn Dev Sandbox, which contains end-to-end use cases for deploying the ERC and KIP standards, contract standards of Klaytn and also Ethereum. So maybe you can also explore that if you are developing some kind of smart contracts. That's all I have for today. And I think you can also go through this link trees of Klaytn Dev and also Klaytn Official. So you can find all the developer related links from this QR. And you can find all the communication related thing from Klaytn Foundation. Just looking at the questions, like, do Klaytn have an account abstraction solution? So right now, I think we don't have it, but we are planning to have one. So our core team is actually working on it. So we are also going to support that. So yeah, I think we still have some time. If you do have any questions, please let us know. And also if you have any questions related to these topics, you can always ping us on Discord, and we have all the communication channels.
Thank you, Praveen. We can end up here. And thanks again for your wonderful workshop presentation. Yes, see you next time.
Sure. Thanks, everyone. Thank you very much. If you have any questions, please drop all the questions on Discord or Telegram. I think our team will be able to respond to them. Thank you. Thank you, everyone.